My name is Moises Martinez and welcome to my presentation on quantum computing. Computers have unquestionably changed the way we live our lives. Since the first electronic digital computer, later named the ABC, and developed by John Atanasoff and electrical engineering student Clifford Berry in the early 1940s, and which could solve systems of simultaneous up to 29 linear equations, or the astonishing first programmable electronic computer in the United States, the ENIAC, which incredibly weighed 30 tons, was 80 feet long, 2 stories high, and performed about 5,000 calculations per second, even more than 10,000 times slower than modern PCs. And in more recent times, the world's current fastest supercomputer, the Titan, which has roughly the computing power of 0.5 million of today's most powerful laptops and took around $100 million to build. The great thinkers of our history have undoubtedly exceeded the expectations of any human being who ever thought such powerful machines could be built. The ingenuity and creativity of our great thinkers has progressively surpassed generation after generation, to the point where most of us nowadays carry a computer 1,000 times more powerful and ridiculously smaller than the ENIAC, and that we only refer to by iPhone, compared to electronic numerical integrator and computer. Sounds funny, but making such comparison illustrates and proves the great achievements and progress humanity has made since the invention of the first computers. Now, everyone wonders, where is it going to stop? What will be the next type of computer? Or will we even have regular desktop, laptops, looking computers like the ones we have now? Because of course, we all assume scientists and the great minds of our current era are developing new ways of making these machines we currently have more powerful. And this is the part where we began exploring into the concept of quantum computing. But before we begin exploring into quantum computing, let's first briefly describe what quantum mechanics is all about. Quantum mechanics explores the behavior of subatomic particles at a nanoscopic or extremely small level. These particles can be the known atomic particles such as electrons, neutrons, and protons. And one of these behaviors that quantum mechanics explores is the movement of these particles from place to place with a particular probability. As the book states, sometimes called the ultimate computer, the quantum computer is based on quantum mechanics, and which in comparison to a normal computer that stores information as zeros and ones, represented by electric currents or voltages that are either high or low, a quantum computer stores information by using states of elementary particles called qubits. For example, a hydrogen atom could be made to switch off and on like a conventional computer's transistors by moving from low energy states off to high energy states on. Another way to describe this is by thinking that a qubit is essentially a binary digit that can take on several or many values simultaneously. This concept of states is what primarily differentiates and makes a quantum computer more powerful from a regular computer. Quantum computers are limited to two states, They encode information as quantum bits, or qubits, which can exist in superposition. To briefly describe superposition, imagine you had a coin which had 1 on one side and a 0 on the other. In a normal state, this coin could be either of those values. But in a superposition state, the coin can be both a 0 and a 1 at the same time. Because a quantum computer can contain these multiple states simultaneously, it has the potential to be millions of times more powerful than today's most powerful supercomputers. So just by imagining that a quantum computer could be millions of times more powerful than today's most powerful supercomputers, it opens up our minds to infinite possibilities these machines will bring for humanity. Some of the aspects quantum computers will demonstrate their mind-blowing strength is in the following applications: breaking ciphers, statistical analysis, factoring large numbers, solving problems in theoretical physics, and or solving optimization problems in many variables. As any other breakthrough or revolutionary technology, scientists researching quantum computing have also encountered difficulties in certain areas. One of the areas is to get particles to behave in the proper way for a significant length of time. The slightest disturbance will cause the machine to cease working in a quantum fashion and revert to single thought model like a conventional computer. Stray electromagnetic fields, physical movements, or tiny electrical discharge can disrupt the process. Despite some of these difficulties, companies like D-Wave Systems, which was founded in 1999 and is the world's first quantum computing company, have been able to develop a quantum computer like their 1000 qubit D-Wave 2X, which they claim it is the most advanced quantum computer in the world. This quantum computer is best suited for complex optimization problems that exist across many domains such as optimization, machine learning, pattern recognition, and anomaly detection. Companies like D-Wave Systems are adding their success to our already revolutionary history since men first decided to tinker into computing. To see and learn about these accomplishments in quantum computing is an amazing experience that motivates me to look into the future of technology and to better appreciate historical breakthroughs.